Hope so the screen is visible for everyone. Let's start now. We have started unit 6, that is the indexing and hashing. Okay, so in that, indexing is nothing but it's a file. Index for a file in a database system works in a much the same way as the index in the textbooks. So after that, what is the indexing in DBMS? Index is nothing but the indexing whichever we are referring while we are using the any textbook, book, reference books. The first part which we are going to see in that is nothing but the index with the page number heading. So because of that, we can easy to find the whatever the points or content we want to search. The same concern is here only. As in DBMS, n number of records we are stored, it's in the thousands or more than that also. So indexing is used to optimize the performance of the database by minimizing the number of disk access and required when a query is processed. See, as an end user or we are just firing the query, we are requesting to the our DBMS, and but at backend in the DBMS, the n number of processes is going on. We got the result very quickly because of the day whatever is the data is stored in that data. Internally we are applying the indexing, like books. The index is a type of data structure. This is a one kind of data structure, and it is used to locate and access the data in the database table quickly. Because of the indexing, we are optimizing the performance of the database. It reduces the time. Okay, so here this is the basic index structure. In that, there are basically two columns are available. That is the search key as well as the data reference. Suppose we want to search a specific record, and that table contains thousands, and we want 513 records. So if there is a no index in, what is happening? We have to go bypass each and every records linearly. 1, 2, 3 up to 512, and after that 513th record we will get. But suppose there is an index saying, then it reduce the time. How? Today we will see these types of indexing too. Okay, the first column in the structure of index, it is a search key. See, search key as well as though the name is key, search key and other keys we already learned, that is the primary key, candidate key. The purpose of the keys over here totally different. Others keys, whatever we are learned, primary key, candidate key, super key, these are the different keys used to identify the records uniquely. And here the search key, as the name suggests, we are using the key to find out, to locate that record, to find out the record, identifying the record uniquely and finding the record from the table. The purpose is different, totally different. So don't confuse in these. Search key and primary key, these are the same. No, not at all. We are creating the different index structure for applying the indexing to the existing tables to optimize the performance of the database. Okay. So in the first column of the database is a search key that contains a copy of primary key or candidate key of the table, and the values of the primary key are stored in a sorted order so that the corresponding data can be accessed easily. Usually, yes, in search key, it may contains the copy of the primary key. It's usually content. which is in the ordered format. Okay, because the whatever why it's required, because whatever is the original table is over there, it may have more than 10, 15, 20 columns. So each and that columns accessing each and every record, it's quite time consuming to go that records. So because of that, we are creating another table, that is the index structure. It only have 2 columns. So it reduces our time. And over here in index structure or structure of index, the second column is the database, is the data reference. The second column of the database is the data reference. We can also say that it's a pointer which holds the address of the disk block, where the value of the particular key can be found. Okay. Hope so you are all getting the concept of the structure of index. If still is there any doubt, let me know. According to the index, there are two basic types. There are two basic kinds of index. There are the ordered indices as well as the hash indices. Ordered indices, this is based on the sorted ordering of the values. How we are accessing the index, how we are going to store the index pattern. According to that, there are two types of indices. First one is the ordered and second one is the hash. In ordered indexes, the whatever index is over there, these are in the ordering of the values. It is in sorted order. And hash indices, it is based on a uniform distribution values across the range of buckets. See, according to the similarity of the uh, content, we are making distribution, uniform distribution in the across overall the values. We will learn these concepts in detail. Just here, just I am explaining the brief in short. Here, values across the range of the buckets. We are creating the buckets. First of all, we are making the uniform distribution of the values, and we are applying that into the one bucket, and the bucket to which values is assigned is determined the function. That function is called as a hash function. Okay. So these are the two types. We learn these two types in detail. So the indexing has the various attributes also, according to their access time, access types, access time, insertion time, deletion time, as well as the space overhead. So access type is nothing but this refers the type of access such as value-based search, range access. Which kind of accessing we are using? It's a value-based search. Okay, and whether it's order or not in order, like that. This is the access type. Then access time, it's refer the time needed to find the particular data elements or set of elements. By using, after applying the index, how much time is required. According to that, we are defining the access time. Then insertion time, yes, it refers the time taken to find the appropriate space and insert a new data. How much time is required to insert a new record on a specific space, appropriate space. Okay, before inserting any record on a specific appropriate space, we have to search that space, and this is also going to happen using the indexing too. Yes, searching is a part of the, but for any kind of searching we require the indexing. That's it. Then the deleting time, again time taken to find an item and delete it, as well as update the index structures, how much time is required. Then space overhead, it refers to additional space required by the index. So while we are applying indexing, whether it takes more space, so according to that we have to think on that too, whether how much space is overhead. Okay, these are the some attributes. We have to think on that attributes while we are learning indexing. Just note down these points. First, two types of indices, then the attributes of indices. So here, here is the diagram of the indexing methods. There are different kinds of indexing method, that is the ordered indices, primary index, then clustering index, secondary index. Again, in primary index, we are categorized that indexing into dense index as well as the sparse index. Today, we will learn these kind of indexing methods with example. Let's see first, that is the ordered indices. Yes, as the name suggests, ordered indices are usually sorted to make searching faster. Hmm? The indices which are sorted are known as the ordered indices. Yes, basically there are two kinds of indices, ordered as well as the hash indices. And the indices which are in the sorted is known as the ordered indices. Examples are, suppose we have an employee table. Consider an employee table with its thousands of records. It includes the thousands of records, and each of which is a 10 bytes long. Thousands records आहेत आणि त्याच्यामध्ये प्रत्येक रेकॉर्डला जी साईज लागती आहे ती 10 बाइट्स आहे. आणि सपोज आपल्याला एखादा स्पेसिफिक रेकॉर्ड फाइंड आउट करायचं आहे, ID 543 अजून, तर वी हॅव टू गो from 1, 2, 3 and so on. We have to bypass from each and every record. So in this case, the database with no index, we have to bypass from these two records, and each record size is what, 10 bytes. So we have to move, we have to fetch total, we are to starting the from the disk search from the 543, sorry, starting till the end reach also 543. So the DBMS will read the record after the 543 into 10, कारण की प्रत्येक रेकॉर्डची साईज काय आहे, 10 बाइट्स आहे, आणि आपला जो रेकॉर्ड आपल्याला सर्च करायचा आहे तो 543 आहे. सो आपल्याला किती रेकॉर्ड्स म्हणजे किती बाइट्स पर्यंत पोहोचायला किती वेळ लागला, आपल्याला 5430. Like that. समजतंय ना? एक टेबल आहे एम्प्लॉई टेबल, त्यात थाउजंड्स रेकॉर्ड आहेत आणि प्रत्येक रेकॉर्ड जे स्टोअर केलेला आहे तिथे त्याला 10 बाइट्स लागतात. म्हणजे टोटल त्या टेबलची साईज झाली 10,000 बाइट्स. लाईक दॅट. अजून आणि त्या रेकॉर्ड्स मधले आपल्याला हवा आहे कुठला रेकॉर्ड? 543 हा रेकॉर्ड आपल्याला आयडीचा हवा आहे. तर तिथे जर इंडेक्सिंग नसेल तर वी आर सर्चिंग सिक्वेन्शियली और लिनियरली. we have to go sequentially one after another. आणि मग आपल्याला रेकॉर्ड म्हणजे आपण इच अँड एव्हरी सर्चिंग मध्ये 10 बाइट्स क्रॉस करत आपल्या रेकॉर्ड पर्यंत पोहोचतोय. सो मग टोटल बाइट्स किती लागले? आपल्याला ते तेवढे रीड करावे लागले ना. टोटल बाइट्स किती रीड्स करावे लागले आपल्याला? 5430. सो इन दिस केस इफ द इंडेक्स इज देअर, मग आपला इथे 2 कॉलम्स आपण इंडेक्स तयार केलेला आहे. सो याला 1 बाइट लागतोय, सर्च कीला आणि डेटा रेफरन्सला 1 बाइट लागतोय, असं अजून करा. कम्पेअर्ड टू ओरिजिनल टेबल कमीच लागेल ना. So in this case of an index, we will search the using indexes. So we will read the record after reading 540 into 2. म्हणजे आपल्याला किती बाइट्स रीड करावे लागले? ओनली 1084. म्हणजे कंपेअर टू बिफोर दिस बाइट्स, it more lesser than this one. So bytes which are very less compared to the previous case. So in this way, index is important to improve the performance. Okay. Yes, ordered index ahe. So it in that whatever is the data structure, index structure is there. It's in order format, sorted one. Okay. And without indexing टेबलला जेवढा टाइम लागतो टू सर्च स्पेसिफिक रेकॉर्ड, त्याच्यापेक्षा नक्कीच इफ देर इज अ ऑर्डर इंडेक्सेस वी आर अप्लाइंग, नक्कीच कमी लागेल. ओके, आर यू गेटिंग स्टुडंट्स ऑर्डर इंडेक्सेस? और मे आय रिपीट? Yes. Are you getting ordered indices concept, indexing?
Yes, ma'am.
Okay, thank you. If is there any doubt, let me know. Okay, let's move to the next point, that is the primary index. This is the another one method, that is the primary index. Yes, the name suggests, see, each and every type has the meaningful name. Order indices means the what is the indexing we are storing index. It is in the sorted order format to make searching faster. And another name is the primary index. That means if the index is created on the basis of the primary key of the table, then it is known as the primary indexing. See, in the primary index, we are going to store the primary key or candidate key values as a search key. Okay, these primary key are unique to each record and contain one-to-one relation between the records. Each records, each and every record has the one-to-one primary index. एका रेकॉर्डला एक प्रायमरी इंडेक्स असेल, दुसऱ्या रेकॉर्डला दुसरा प्रायमरी इंडेक्स असेल, like that. These primary key are unique to each record and contain one-to-one relation between the records. And as primary key are stored in a sorted order, the performance of the searching operation is quite efficient. and we are also storing this primary key index, sorry, not a primary key, primary index in a sorted order. So primary index can be classified again into two types. Yes, dense index as well as the sparse index. There are two types of primary index. First one is the dense and second one is the sparse index. But for searching, we are using the primary key of the tables in the search key. Okay. Let's see first dense index now. Yes, the dense index contains the index record of every search key value in the data file. It makes searching faster. जो प्रायमरी इंडेक्स मध्ये आपण कन्सेप्ट बघितला तोच कन्सेप्ट आहे जो डेन्स मध्ये आपण यूज केलेला आहे की प्रत्येक रेकॉर्ड साठी आपण इंडेक्स की तयार करत आहोत. In this number of record, the index table is same as the number of record in the main table. Suppose, see over here now. हा आपला टेबल आहे. Here the number of records of index table आणि हा इंडेक्स टेबल आहे. हा मेन टेबल आहे किंवा रिलेशन आहे आणि हा आपला इंडेक्स टेबल आहे. सो इंडेक्स टेबल मधले जे रेकॉर्ड्स आहेत ते ऍज द नंबर ऑफ रेकॉर्ड्स इन द मेन टेबल सेम आहेत. इथे 4 रेकॉर्ड्स आहेत आणि इकडे पण 4 आहेत. म्हणजे या मेन टेबल मध्ये जेवढे रेकॉर्ड्स असतील तेवढेच रेकॉर्ड आपल्या इंडेक्स टेबल मध्ये सुद्धा असतील. Because it maintains the one-to-one relation. So it makes searching faster because of indexing, but it needs more space to store the index order record itself. It needs more space to store index record itself. कारण की आपल्याला जेवढा आपला टेबल आहे तो फास्टर होतोय कारण की आपल्याला नंबर ऑफ बाइट्स जे रीड करायचे आहेत ते कमी होत आहेत बिकॉज ऑफ इंडेक्स स्ट्रक्चर मुळे. बट एक्स्ट्रा स्पेस पण लागते ना. The index record have the search key and a pointer to the actual record of the disk. इथे बघा search key पण आहे ही and here is the pointer which holds the address of the actual record on the disk, but it needs a more space. That's why as we are maintaining here one-to-one and it's as same as the main table, that's why it's named as a dense. Okay. So while we are applying the dense index to our table, it may require or it required the more space. So though its address quick search, this is the drawback or disadvantage of the dense index. Any search key, the space used to index an address becomes overhead in the memory. Here the index and address becomes almost same as the table record. Hence more space is consumed to store the index as the record size is increased. छोटा टेबल असेल तर इट्स ओके, बट जसा तुमचा टेबल साइज इन्क्रीज जाईल तसा तुमचा इंडेक्स टेबल सुद्धा इन्क्रीज होत जाईल. ओके, दिस इज द ड्रॉबॅक ऑफ द डेन्स इंडेक्स. ओके, so next type is the sparse index. Yes, now we know the dense index and it's working as well as its drawback. So इंडेक्सिंग तर पाहिजे आहे पण त्याचे ड्रॉबॅक्स पण मिनिमाइज झाले पाहिजे, कमी झाले पाहिजे. टू ओव्हरकम दॅट डेन्स इंडेक्स ड्रॉबॅक्स, there is a sparse index is there. Here to address the issue of the dense dense indexing, sparse indexing is introduced first. So how to overcome that drawbacks? So in this method of indexing, range of index columns stored in the same data blocks. What is the range of index? It is stored in the same data blocks address, and when the data is to be retrieved, the block address will be fetched linearly till the get the requested data. Okay, we will see with the diagram. It is in the data file index records appears only for a few items. Each item points to a block. See, sparse index मध्ये आपण each and every जो रेकॉर्ड आहे टेबल मधला त्या प्रत्येक रेकॉर्डला आपण पॉइंट आउट करत नाही. Instead of pointing to each and every record in the main table, the index point to the record in the main table in a gap. Gap ने आपण point out करतोय. Let's see this with an example. See. See now, this is our main table and this one is the sparse index. Now, here to in the data blocks in memory, total records, if you are looking carefully, there are 9 records. But in the sparse index, we are storing only 3 index value. Means we are pointing to the record with a gap. मग सर्चिंग कसं करायचं? इथे आपण बघा फर्स्ट आपण 100 रेकॉर्ड आहे तो 100 ला पॉइंट आउट करतोय. नंतर 103 आहे तो आपण पॉइंट करतोय, म्हणजे 2 रेकॉर्ड हे स्किप केले. जसं आपण डेन्स मध्ये इच अँड एव्हरी रेकॉर्डला आपण पॉइंट आउट करत होतो. इट्स 1 to 1 रिलेशन. बट इथे आपण टू रिड्यूस द मेमरी साइज आपण काय करतोय, गॅपने पॉइंट आउट करतोय. In above diagram, we can see we have not stored the indexes for all the records. Instead, only 3 records indexes are stored. Now, if you have a search of student with ID 102, how to find out that one? Then the address for the ID less than or equal to 102 is searched first. We are comparing the search ID, student ID, and start with the address which is less than or equal to 102 in search, and which returns the address of ID 100. And this address location is then fetched linearly. पहिल्यांदा आपण काय करतो, 102 आहे ना, तर 102 आणि त्याच्यापेक्षा लेसर व्हॅल्यू हे स्पार्स इंडेक्स मध्ये सर्च करतो. तर ती कुठली आहे, तर 100 मिळाली आपल्याला. तर 103 इज ग्रेटर दॅन द 102. आपल्याला मिळाली व्हॅल्यू 100 आहे. तर डायरेक्टली आपण त्या रेकॉर्ड वर जातो आणि मग तिथून लिनियरली 100 नंतर लिनियरली आपण 101, 102 हा असा रेकॉर्ड सर्च करतो. and it is whether is it same with our search key? Yes, of course. And this address location is then fetched linearly. Here we are fetching linearly after 100, 101, 102 until get the record of 102. Hence, it makes the searching faster and also reduce the storage space for indexes. Okay. Are you clear with the concept of the dense index, sparse index? Are you getting, students? Or may I repeat? Yes. Are you getting dense index, sparse index? We are learning the primary index. In that there are 2 types of index, dense and sparse. Hello, are you there?
Yes, ma'am.
Okay. Are you getting the concept?
Yes, ma'am.
Okay. Thanks for the response. Now, yes, using tens sparse index, we are overcoming the drawback of the tens index. But in the sparse index, as the table size grows, mapping file size also grows. Here is the mapping, hmm, 1, 2, 3. Mapping size also grows. So in the memory, usually these mappings are kept in the primary memory. जो काही आहे ते मॅपिंग आपण करतो तो टू ऍक्सेस फास्ट. We are keeping these mapping into the primary memory, and usually these mappings are kept in primary memory so that the address space should be faster, and the latter the actual data is searched from the secondary memory based on the address got from mapping. If the size of mapping grows, the fetching of the address itself becomes slower. स्विचिंग म्हणतात ना, कंटेक्स्ट स्विचिंग, आपण फेचिंग करतो ऍड्रेस, तो पण वाढेल ना जेव्हा तुमचं परत डेटा अगेन इन्क्रीज होतोय. तर मॅपिंग ऑल्सो इन्क्रीज as well as the fetching time also get increased, and at the end it's become slower. Hence sparse index will not be efficient if the data size or record size is more. So again, to overcome the primary index drawbacks, here the another index type is method is get invented, that is the secondary index. Okay, to overcome the primary index problem, mostly in sparse index. Next version of the sparse index is introduced, that is the secondary indexing. Yes, it reduces the size of mapping. पहिल्यांदा मेमरीचा प्रॉब्लेम होता आपल्या डेन्स मध्ये, की मेमरी त्या टेबलला जास्त लागायची, म्हणून आपण स्पार्स इंडेक्स क्रिएट केला. ऑफकोर्स मग त्या टेबलची जी आपलं इंडेक्स स्ट्रक्चर टेबल जो आहे त्याची साईज कमी झाली, बट अगेन द साईज गोज इन्क्रीज इन स्पेस स्पार्स इंडेक्स, mapping sizes get increased. So the main concern is now to reduce the size of mapping. For that, another level of indexing is introduced. So that's why it's called the secondary index. It reduces the size of mapping, and how it is reduced? We are creating the another level of indexing. In this method, the huge range of columns is selected initially, and so that the mapping size of the first level becomes small. Then each range of is further divided into smaller. See, I am reading this one more time. The huge range of the columns. Huge range of the columns is selected initially. And it is selected, just a minute, it's stuck. Am I audible?
Yes, ma'am. Audible.
Okay. See, in secondary index, we are creating another indexing level. प्रायमरी इंडेक्स मध्ये एकच इंडेक्स लेवल होती, जस्ट एक सेपरेट आपण टेबल क्रिएट केला. पण सेकंडरी इंडेक्सिंग मध्ये काय करतो, आणखीन एक आपण इंडेक्सिंगची लेवल तयार करत आहोत. हा म्हणजे टोटल तिथे 2 लेवलचे इंडेक्सिंग झाले. मग पहिल्यांदा काय करतोय आपण की ह्यूज रेंज ऑफ कॉलम इज सिलेक्टेड इनिशियली. म्हणजे आता सपोज द 1000 मेन टेबल आहे, त्यात 1000 रेकॉर्ड्स आहेत. मग आपण ब्लॉक्स तयार करत आहोत किंवा जे इनिशियली रेंज तयार करणार आहोत ती 100 ची केली असं कन्सिडर करा. Assume over here, this is the data block in memory, this is our main table. मेन टेबल आणि आपण यूज रेंज ने इथे प्रायमरी लेवल इंडेक्स तयार करत आहोत. इथे सी 100, 200, 300 म्हणजे टोटल इंडेक्सिंग किती झाले इथे, अराउंड 9 झाले. 1 to 9 इज इट. 1000 रेकॉर्ड साठी 100, 200, 300, 400 लाईक. म्हणजे इच जे आपण पार्टिशन्स केलेले आहेत त्याच्या अंडर किती रेकॉर्ड्स आहेत, 1 to 100 असं तुम्ही कन्सिडर करा, लाईक दॅट. तर हा मेन जो आहे तो त्याच्यामध्ये मोर गॅप्स आहे. हे आपण पहिल्या लेवलला केलं. हा या स्टेटमेंटचा मीनिंग आहे. इन दिस मेथड द ह्यूज रेंज ऑफ कॉलम्स इज सिलेक्टेड इनिशियली, ह्यूज रेंज ऑफ कॉलम्स, so that the mapping size of the first level become small. याच्यापेक्षा याची इथून मॅपिंग करते म्हणून स्मॉल झाली. अगेन what we are doing, then each range is further divided. इथे 100 ची रेंज आहे ती अगेन further divided into smaller range. And the mapping of the first level is so stored the primary memory so that the address fetch is faster. See, total इथे 9 आपण पार्टिशन्स केलेले आहेत. 100 कॉलम सिलेक्ट केलेले आहेत आणि नंतर 100 रेकॉर्डचा एक ब्लॉक याचं अगेन आपण स्मॉलर ब्लॉक्स मध्ये डिवाइड केलेले आहेत. ओके. आणि मग आपल्याला ऍक्सेस तरी फास्टर हवा आहे, पण मॅपिंग हे कमी व्हावं फ्रॉम प्रायमरी टू सेकंडरी मेमरी. म्हणून जो पहिला प्रायमरी इंडेक्स आहे, लेवल आहे, प्रायमरी लेवल इंडेक्स, तो रॅम मध्ये म्हणजे प्रायमरी मेमरी मध्ये स्टोअर केला आणि नंतर परत स्मॉल साइजचे जे मॅपिंग्स क्रिएट केलेले आहेत ते हार्ड डिस्क मध्ये स्टोअर केले. ओके. सो इट रिड्यूस द मॅपिंग. The mapping of the second level and actual data are stored in the secondary memory, that is the hard disk. So let's take example of over here. Now listen carefully. If you want to find the record of roll number 111, see this present here. You want to search this record 111 in the diagram, then it will search the highest entry which is smaller than the 111 first. So in this primary 100, and it will get at 100 at this level, highest entry but which is lesser or than or equal to 1100. हे आपण पहिल्यांदा बघू. Then the second index level again does max 111 and less than equal to 111 and it gets over here. इथून आपल्याला आपण सर्च करतोय तर आपल्याला हे मिळतोय 110. Now using the address 110, it goes to the data block and start the searching each record till it gets 111. This is how the search is performed in this method, and inserting, updating or deleting also done by the same manners. See, secondary index आहे म्हणजे आपण अगेन एक इंडेक्स लेवल क्रिएट करत आहोत. एक पहिली आहे जी लार्ज गॅपने आहे, 100 रेकॉर्डच मॅपिंग करत आहोत आणि अगेन आणि तो प्रायमरी मेमरी आहे त्याच्यामध्ये स्टोअर करत आहोत. आणि दुसरा अगेन तो जे मॅपिंग केलेले 100 अगेन वी आर डिवायडिंग दॅट इंटू द स्मॉलर blocks and which is going to stored into the hard disk. That is the secondary level index or secondary memory you can say. आणि नंतर इथून मग आपण पहिल्यांदा कुठला रेकॉर्ड आहे त्याची चेक केला की प्रायमरी लेवल मिनिमम कुठला आहे और इक्वल टू कुठला मिळतोय, तर तो 100 होता. नंतर आपण सेकंडरी लेवलने मॅपिंग करून त्यामधला लेसर व्हॅल्यू और इक्वल टू व्हॅल्यू फाइंड आउट केली, दॅट इज 1110. आणि मग नंतर इथून इकडे आपण लिनियरली जोपर्यंत 110 नंतर इकडे जोपर्यंत 111 फाइंड आउट होत नाहीये तोपर्यंत आपण इथे लिनियरली सर्च करतोय. ओके, this is all about the secondary indexing. CR of the board, the division, please take a screenshot of the attendance. CR A division, CR B division, please take a screenshot of the attendance. Then the multi-level index. As in secondary index, we are creating the 2 level of indexing. In multi-level indexing, we are creating more than 2 levels of indexing. In this method, we can see that index mapping's growth is reduced to considerable amount, but the method can also have the same problem as the table size increase. In order to overcome this, it is introduced a multi-level between the primary and the secondary memory. See, आपण सेकंडरी मध्ये 2 लेवल्स क्रिएट केल्या इंडेक्सिंगच्या आणि मल्टी लेवल मध्ये आणखी लेवल्स तयार करतो. त्यामुळे त्याला मल्टी लेवल इंडेक्सिंग हे नाव आहे. Yes, mapping growth is reduced in multi-level indexing, but as the size is increased, the same problem in order is created. This method is also known as a multi-level indexing. In the method, number of secondary level indexes 2 or more. Okay. So today we will stop here only. Is there any doubt? Let me know. Any query? Yes, one of the thing on Monday, there is a unit test on unit 5. So be prepared for the same Monday. Are you there, students? On Monday, there is a test on unit 5. So be prepared. Be prepared for the same. Today we will stop here only. Thank you, everyone.